Hi guys, can you solve 9 power x plus 3 power x is equals to 20? In this tutorial, we are trying to provide the value of x that will satisfy this initial problem we have on the board. Okay, for us to solve this is very simple. What do we see? 9 power x. You understand that 9 and 3 can be expressed in common base, but 20 can't. So what do? We'll now write them to be in common base. So instead of having 9, I can say 3 squared. So if I have 3 squared, then already existing power x plus 3 power x is equals to what? 20. So nothing changed, right? But again, you should recall the law of exponents, which says that a to the power of b, then raised to the power of c, can be written as a power c raised to power b, that the order of the power is never a problem. If you understand this now, we are going to apply it exactly here, so that we'll swap the positions of 2 and x. So we can say 3 power x all squared plus 3 power x is equals to what? 20. Okay? So if you have this now, we can now clearly redefine the terms of x. Okay? So here, we can now say, let y be equals to 3 power x. If we choose y to be 3 power x, we can now replace each term of 3 power x to be y. Okay? If you understand this now, we can now say that y squared, because 3 power x is now defined to be y, then plus 3 power x is here. So I'll say y is equals to what? 20. Okay, this clearly looks like a quadratic equation. So to confirm that, we have to subtract 20 from both sides. So we have it as y squared plus y minus 20 is equals to 0. Okay, this is a clear quadratic equation. So to solve this, we are going to check whether we can solve by factorization. Is there any two numbers that multiplies to get minus 20? But if you add them together, we get a positive 1. Yes, because when you multiply negative 4 to positive 5, it gives you negative 20. If you add them, you're having 1. So we can now use it to expand, showing that y squared minus 5y plus 5y minus 4y minus 20 is 0. Now we'll group the first two terms and group the last two terms. So here we'll factor the common term, which is y, then y into y plus 5, then factor the common term here, minus 4. Minus 4 into y plus 5, and that's 0. You can now see that these two brackets are the same. We'll form a unit bracket, y plus 5 into the terms multiplying them, y minus 5 is equals to what? 0. Okay? So when two things multiplies to give 0, one of them is 0, or we equate both of them to be zeros. So we have that y plus 5 is equals to 0, or we say that y minus 4 is equals to 0. Okay? So if you have that, you can now see that y is equals to minus 5. For the first one, we subtract 5 from both sides. Then for the second one, y is equals to, we are adding 4 to the both sides, 4. Okay? So let's test the value. You know we say that our y is equals to 3 power x. So since we accept y to be 3 power x, we can now say that 3 power x is equals to, the first value there is 4. Okay? Again, we now fix a tax because we cannot express these two to be in the same base. So we take the log of both sides. So if we take the log of both sides, okay, the log allows us to multiply x to the power. X is now the power. We have it as log 3, and that's equals to log 4. Okay? Then the next thing is to divide through by log 3 and divide through by log 3. If you divide through by log 3 will be cancelled out. X is equals to log 3 over log 4. We can express them to be in uniform using change of base. The log of the denominator base becomes the base, and we have 4. So the answer is log of base 3 of 4. That's the answer to this particular problem, the first solution. Then the second solution is that y is equals to 3 power x. Then our y is equals to minus 5. That's 3 power x is equals to minus 5. We don't accommodate for a negative solution. So there is no real solution for this using this. So the only solution we are going to take is the log of base 3 of 4. Like and share this video for more exciting math tips coming up next. Bye.